Okay, let's discuss some examples with polarization. Let's start with the simulation. Oops. Okay. Here we go. What we do, we have two polarizers. Okay, come on. First, we set them up such that their transmission axes are parallel. Both of them are at 0 degrees. And we have the tiger behind. So we visibly see the tiger, ideally with no change in intensity. The intensity of the light after the first polarizer and after the second polarizer are the same. Now, if we rotate this by 90 degrees, so the transmission axis of the second polarizer is perpendicular to the first polarizer, then the intensity after the second polarizer is absolutely zero. Now, notice if I have an angle between these, the intensity that we see is going to be I0, which is 1 in this case, cosine of the angle squared. Cosine in this case 37 degrees squared. Okay. That's the whole idea. The first polarizer polarizes the light along the horizontal. The second polarizer is going to polarize it at whatever axis we choose it at. Now, if the axis is perpendicular to the first, it's going to be 0 transmitted intensity. For all other angles, we have to calculate. It's going to be I1 times cosine of the angle between the both transmission axes squared. A few questions here. Unpolarized light, like light from the sun, passes through a polarizer in sunglasses. The intensity of the light when it emerges, what is it? Let's remember, ideally, a polarizer is going to cut 1/2 of the intensity of unpolarized light. So our answer should be answer 2. Now, if we have horizontally polarized light passing through the same glasses, which are vertically polarized, the intensity of the light when it emerges is 0, because vertically polarized is perpendicular to the horizontal polarization axis of the light, so the angle is 90 degrees and the passing intensity is then 0. Okay. Now another example. So here we have unpolarized light. Before any polarizer, our intensity is S sub 0. After the first polarizer, our intensity is going to be 1/2. The second one, its axis of polarization is perpendicular to the first, so the intensity is 0. Very simple, just a rehashing of what we just said. Okay. Now let's take this case here. First polarizer, intensity is before it's I0. So the intensity here, just after the first polarizer, we are going to have light only along the transmission axis passing through. The intensity is going to be 1/2. Now, the second polarizer has its transmission axis at an angle of 45 degrees relative to the polarization of the wave. So now intensity 2 is going to be 1/2 times cosine of 45 degrees squared. Cosine of 45 degrees squared is 1/2, so I2 is going to be 1/4. So I'm going to have I0 over 4 here. Now the last polarizer is going to have its angle again making an angle of 45 degrees relative to the polarization angle of the wave. Remember, the wave here is making an angle of 45 degrees relative to the vertical, so the transmission axis is making a 45-degree angle with it. So my I3 is going to be I2 cosine of 45 degrees squared. So it's going to be I2 over 2, and then I2 is equal to I0 over 4, so it's going to come out to be I0 over 8. So I3 is I0 over 8 in this particular case. Okay, let's try it out with that simulation. Okay, so let's move this a little bit. Now we don't have unpolarized light here, and actually this simulation does not show us intensities. But let's try a light that is at circular polarization. Okay. Now the first polarizer is going to allow only light parallel to the axis to go through, and actually to be in accordance with the text of that particular question. So I'm going to set up my transmission axis along the vertical. So this is what we see. Now for the second polarizer, now we place it here and we position its axis at 45 degrees relative to the first beam. Okay, so there's 45 degrees. Now look what happens. Okay, so light is going to come out parallel to the transmission axis of that polarizer. Light here is parallel to this axis. Here it's going to be parallel to the second axis. Okay. Now for the third polarizer, if we have it at this angle, then the light relative to it is again making a 45-degree angle relative to its transmission axis. So the only part that's going to pass, okay, let's give it some distance so we can see more. So the only part that's going to pass is going to be the part that's parallel to the transmission axis of the last polarizer, and that's what we get out of the three of them. And this is actually an interesting example, because you notice here we have the first polarizer perpendicular to the last one, but we still get some light out, and that's because the middle one is actually rotating the polarization of the light before it gets to the third one. We can see the same thing with this simulation. Okay, now the first polarizer is at 0. The second polarizer, we are going to put it at 45 degrees angle. Okay, let's see. So this is actually the third polarizer. So let's add the middle one. Okay, let's see where's, yeah, so this is the middle one. So we set it at 45-degree angle. Okay. Now, first polarizer is horizontal in this particular case. The middle one is at 45 degrees. And the last one is at 90 degrees perpendicular to the first one. And we still see light. Now, of course, If the middle one becomes parallel to the first, we don't have any light passing through. Same thing if it is parallel to the third one. 45 degrees is the angle that's going to give us the most light out. Okay, a couple of questions here. We have two configurations. In the first configuration, we have the light is polarized along the vertical, and we have the first polarizer having a transmission axis of 60 degrees relative to the vertical, and the second polarizer with a transmission axis along the horizontal. In the second case, the second polarizer has its transmission axis along the vertical. And the question is asking which one is going to result in more light being transmitted. Okay, now so in both cases we are going to have the same S1. The difference is what's going to happen with the last polarizer. Remember, S2 is going to be equal to S1 cosine of theta squared. Now theta is going to be the angle between the transmission axis of the second polarizer and the direction of polarization of the light, which is the same as the transmission axis of the first polarizer. So in this particular case, the angle is 30 degrees. So it's going to be S1 cosine of 30 degrees squared. In the second case, what do we have? It's perpendicular. So the angle theta between the transmission axis and the axis of polarization of the light is actually 60 degrees. Meaning S2 is going to be equal to S1 cosine of 60 degrees squared. Remember that cosine of 60 is 1/2, while cosine of 30 is very much close to 1. .867, something like that. So that tells us S2 for A is larger than S2 for B. If the angle here of the second polarizer was 45 degrees, we will get the same intensity out.